This video is about calculating convergence with spreadsheets. We'll review the equations for calculating convergence and then work an example using a spreadsheet. Let's get started. These are the sets of equations that we provided in a separate video. They are for calculating convergence. Each set has an equation for p sub k, the numerator of the convergent, and for q sub k, the denominator. Which set you use depends on the subscript k. The way it works is you start by using any two consecutive sets from these four sets to find a consecutive pair of convergence. This gets you started. Then, you use this equation for the remaining convergence. The reason you need to use two of the other sets first is the equations in this box assume you already know two previous convergence, p sub k minus 2 and q sub k minus 2, and p sub k minus 1 and q sub k minus 1. For this video, we'll use these two sets to get started, and then, of course, use this set. We'll do all this in a spreadsheet. For our example, we'll calculate convergence for the square root of 19. It equals, as a simple continued fraction, 4, 2, 1, 3, 1, 2, 8, with all but the 4 repeating. Here's a blank spreadsheet. I'm using Google Sheets, but what we're going to do will work also in others such as Excel. We'll have rows for K, A, P, and Q. K starts at minus 2 because we're starting with this equation, and we'll make it go up to 12 for our example. We'll put the simple continued fraction in the row for A. There aren't terms to put in the columns for K equals minus 2 and minus 1, but after that, we have A equals 4, 2, 1, 3, 1, 2, 8, and then, starting with the first two, it repeats. We have 2, 1, 3, 1, 2, 8 again. It is an infinite simple continued fraction, so it continues indefinitely, but we have to stop our calculation somewhere. Now we'll enter values from this set of equations in the column for k equals minus 2, p equals 0, and q equals 1, and the values from these equations in the column for k equals minus 1, p equals 1, and q equals 0. Alright, now we're ready to enter this equation, starting at k equals 0. But first, let's make this look a little nicer. We'll make the row and column names bold and set them off with lines, and we can also shade them light gray. And we can shade the first two columns, since they are just there for the calculation and don't really have convergence. There. You don't have to do anything like this, but it looks a little nicer. Now, we'll use this set of equations, starting with k equals 0. P0 goes here. The address of this cell is D3. We need the equation for P0 in terms of the relative cell addresses. Let's see how to do that. Here is the generic equation for P sub k. It's what's in the set of equations up here. When k equals 0, the equation is P0 equals p sub minus 2 plus p sub minus 1 times A0. In this spreadsheet, p sub minus 2 is in this cell. The address is B3, p sub minus 1 is here in C3, and A0 is here in D2. We can put these addresses in the equation, and it becomes P0 equals B3 plus C3 times D2. We'll type this in. B3 plus C3 times D2. We have P0 now. For Q0, it is very similar. Here is the generic equation, the same as what's in the box above. When k equals 0, the equation becomes Q0 equals q sub minus 2 plus q sub minus 1 times A0. Q sub minus 2 is here in B4, q sub minus 1 is in this cell in C4, and A0 is in D2. The equation becomes B4 plus C4 times D2. We'll type this in. B4 plus C4 times D2. We have our first convergent. P0 over Q0 is 4 over 1. After calculating this, the rest is a breeze. This is one of the things that is great about spreadsheets. All we have to do is highlight these two cells that we already have equations for, grab the handle, and drag it over to the column for our last convergent, where k equals 12. The software adds the equations in these cells, and the addresses update automatically. Now we have the convergence for the square root of 19, up to including k equals 12. Here's another great thing about doing this in a spreadsheet. It's really easy to replace the values of a with values from a different continued fraction. Let's do that. We'll delete what's in the row for a now and enter values for the square root of 7, which is 2, 1, 1, 1, 4, with all but the 2 repeating. The 2 goes here, then 1, 1, 1, 4, and then the 1, 1, 1, 4 repeats, and we have enough columns for the third period, so 1, 1, 1, 4 appears again. The cells with P and Q updated automatically as the values got filled in. Now we have the convergence up to k equals 12 for the square root of 7. And here is the square root of 5. It is 2 followed by 4 repeating. We can delete the current values of A and put these in. Oops, it's 4 that repeats, not 5. This time the values of P and Q grow more quickly, so the columns are a little too narrow. We'll fix that, and have to zoom out a bit. It's that easy to change the values of the simple continued fraction, and you don't have to restrict yourself to square roots or even irrational numbers. Plus, you can duplicate the cells into additional rows on the same sheet or into a new sheet. You have all kinds of options. Once you have a spreadsheet like this, it can be very convenient, and, assuming the equations are entered correctly, you can rely on the spreadsheet to calculate the convergence over and over without making errors. In this video, we reviewed the equations for calculating convergence and saw how to calculate them with a spreadsheet. That's all for now.